Linear graphs. So a linear graph is essentially any graph that is a straight line. So for example, this red line is a linear graph. Now this is increasing. You could also have a decreasing linear graph. For example, the one drawn in blue. Now your graph will have a y-axis and an x-axis. And say, for example, you are asked to draw the equation y equals x plus 2. Essentially, for this, because this takes the format of the straight line equation, y equals mx plus c. So here the m is 1 and c is 2. We know that the graph will be a straight line. Now on a straight line, if we were to draw 2 points and join them together, we have the straight line. So we essentially need to calculate 2 points of this equation to draw this line. However, we will do a third point as a check, because if the third point is over here, it will tell us that something has gone wrong because it's not a straight line anymore. Whereas with 2 points, we could effectively draw the wrong graph, but it'll still be a straight line. So for example, this blue line is also a straight line, but it's very different to the purple one we drew earlier. So what we do is we populate this table where the top values is x and the bottom values is y, and we choose any 3 points, so any 3 x values. So for example, let's do -2, 0, and 2. So now when x equals -2, we plug that in, so we get y equals x goes to a -2 plus 2. So this is 0. So we can populate that one in here. Next one, x equals 0. So y equals x. So now x is 0. So we put 0 in there, plus 2, which is equal to 2. So we can put 2 in there. And the last one, x equals 2. So y equals x, which is now 2 plus 2, which is equal to 4. So we can put 4 in there. So the first coordinate we're going to plot is -2, 0. So -2, let's say that's -1. That's -2, and it goes to 0, so we go put that point over here. Next one is 0, 2. So 0's here, and we go up 2 to there, and that's our next coordinate. The next one is 2, so we go 1 and 2, and then we go up 4, so let's say that's 3, and then that's 4, so that's about here. So then we draw our straight line. So now we have the straight line going through the 3 points, and we have drawn the equation y equals x plus 2. Now let's understand this equation. So m we said was value 1, so that means that for every step we take to the right, we go up by 1. And similarly, for every step we go to the left, we go down by 1. Because it's a positive 1, it's an increasing. So positive equals an increasing graph. Now let's look at the second number, 2. So this is the constant at which it crosses the y-axis. So here, so we actually calculated that here. So 0, 2. So it tells us that it intercepts the y-axis at 2. So this is your intercept. Now let's look at another example. Now let's say you are given the graph drawn with the coordinates. So here we've got -2, 0, 0, 2, and 2, 4. And you are asked to work out the equation of the graph. We can see that the graph is a straight line, so it must take the form y equals mx plus c. So now, as we knew that c is your intercept, and the intercept is at 2, so we know c equals 2. And then we can rewrite our equation as y equals mx plus 2, and use any of the coordinates that we know, 1, 2, or 3, any of those as they are on the straight line. So let's go with 2 and 4. So that means that the y value is 4. So let's replace y with 4. Equals m, we don't know. X is 2 plus 2. And then we solve. So we take 2 away on both sides. So this becomes 2 equals 2m. m2 and 2m is the same, it's multiplying. So m equals 1. So now we know that our equation is y equals m is 1, so it's just x plus 2. So now we have worked out our equation. Now, this is one approach. Another approach is take 2 of the coordinates. So for example, we can use 0, 2, and we can take 2, 4, plug it into the equation. So we have 2 equals 0m, which is just 0, plus c, and we have 4 equals 2m plus c. So now we have 2 equations and 2 unknowns, so we can solve using simultaneous equations. Note, you don't need to know simultaneous equations to solve. You can use what we did previously. However, this is another approach. The third approach is that the m is equal to the gradient, which is the change in your y all over your change in your x. So for one step here, so we look for the change in x between 2 points we know. So for example, we know 0, 2, and 2, 4. So this going across the x-axis, we've gone over by, so we just do 2 take away 0. And changing in y's would be 4 take away 2. So we're using these coordinates over here. And then we simplify. So we get 2 over 2, which is 1. So our gradient is 1. So we know it's y equals x plus, and again, we use the intercept, which is 2 as our value for c. So y equals x plus 2. So now let's consider where we do not have an increasing graph. So let's say we have this equation here, and let's mark the coordinates. So we have 1, 2, 1, 2, and coordinate here is 2, 0. This point is 0, 1, and let's mark another one over here, which is minus 2, 2. So here, because it's a decreasing graph, we know that if a graph is decreasing, then m is negative. If, like the previous one, is increasing, then m is positive, so the gradient is positive. And if it's flat and it's horizontal, then the gradient equals 0. So here, because it's a straight line, we know the format is going to be of y equals mx plus c. And we can tell that the intercept is 1. So because it crosses the y-axis at 1, so we can say plus 1. And the gradient, let's use one of the 3 approaches. So we said change in y's over change in x's. So going from this point to this and the equivalent y numbers, we say the change in y's goes from 0 minus 1. And notice I put this one first, then this one. So you have to keep it in the same order for the x's. So it's 2 minus 0. So this is equal to minus a half. So we have a minus a half x equal to y. So this is your final equation. Now we can test this equation with the third coordinate. So y equals 2 minus a half x plus 1. We replace the numbers. So y is 2 minus a half times minus 2 plus 1. So minus a half times minus 2 is 1 plus 1, 2. And 2 equals 2, which is correct. So we found the right equation.
You can download the application on Google Play or App Store, and you can visit our website mathslegends.co.uk.